Hello, in this video we're looking at part 2 of transformations in matrix form. Transformations in matrix form part 2, and this is for learning intention 40. Now if you haven't done so already, please try to derive all the expressions in the last video by yourself. So start with 1, 1, do the little sketch, start with 1, 1, and have a play around and see if you can figure out what each of the elements in the matrices do to the point. That's really important to get a feel for that. After you've done that, we can look at this trickier example. So if you haven't done that, stop the video, go back, do it. Really important. So this is question 9 from the exercise, and I've chosen this question on purpose because it combines a lot of the concepts with previous concepts of DRT and how we learned that. So a function g of x is mapped to the curve h of x. So we're going from g of x to h of x via some transformations. And what the question wants us to do is create a matrix equation that will do this. So it's shown us how to do it here with DRT. What we need to do is decode the DRT and re-encode it, if you like, into the matrix form. That's what we're needing to do here. We're going from understanding transformations in terms of DRT to understanding them in terms of matrices. So the first thing to do is to take h of x and break it down in terms of dilation, reflection, and translation. So let's look at dilations. Are there any dilations here? Dilations, I can see one. So we can see that the 4 is inside the function, so it's on the inside. So that means there's a dilation by a factor of 1/4. Don't forget it's on the inside, so you've got to take the reciprocal by a factor of 1/4 from the y-axis. So there's our dilation. Any reflections? Let's see. I can see a negative sign out the front. Now, negative sign out the front means it's flipped in the x-axis. So it's outside the function g of x, the negative sign. So we have a reflection in the x-axis. Alright, let's look at our translations. We do have translations. I can see 3 units up, 3 up, and 1 to the left. 1 unit to the left. 3 units up, 1 unit to the left. Now we need to take this information and create a matrix equation that will do this. Okay, well let's see what will that look like. Well, we'll start with, it's going to be, I'm going to do this really formally. We're going to define T such that it is a mapping from one point in the Cartesian plane to another point in the Cartesian plane, such that T takes that point and it's going to do some stuff to it. Alright, what's it going to do to it? Well, we're going to start with our square matrix. Let's put this information in here. So let's see, we have a dilation by a factor of 1/4 from the y-axis. So we know our dilation goes here. For y, we have a reflection in the x-axis. So that means a -1 here. And we'll put our point xy there. Now translations. Okay, so this is going to be a column vector. So we have 3 units up and 1 unit to the left. So I've got to be careful here. To the left, that's going to be in the x direction to the left, and that's going to be negative. So it's going to be -1. And 3 up, well, that's the y there. That's your answer. You've taken dilation, reflection, and translation, how we learned it in terms of DRT, and we've written it in terms of matrix form. If you understand everything there and you're comfortable with that, you should be very comfortable with the rest of the exercise. And if you have been, thanks for watching.